Alright, so this is going to be a quick tutorial about ionization energy. So what is ionization energy? It's basically just the energy required to remove an electron from an atom. Okay, so say you have an atom X. If you add a certain amount of energy, this ionization energy, you will get that same atom only as an ion this time, so it's charged because it lost an electron. Okay, so you have some atom X, and then you add some energy, some ionization energy, and then it makes that atom positively charged and also kicks off an electron from that atom. Okay, it's measured in kilojoules per mole, but we're not really going to worry about that too much until we go over moles. Okay, and a way to show ionization energy is through this animation. So I'm going to go through this animation real quick. So you have this atom, and it's got this electron right here that's on the first shell. So here's the nucleus, here's the electron shells, and that green thing is the electron. Okay, if you add energy to an atom, it could jump up to another shell or another shell, and if you take it away, it just jumps back down. But if you add enough energy to it, so that's a more energy even to it, you can actually cause the electron to just completely leave the atom. Okay, now when this happens, that's what we call ionization energy. It's enough energy where it actually makes that electron fly off like it did right there. So since it flew off, now you just lost the negative. Because you lost the negative, now the atom becomes positive. Okay, so the definition of ionization energy again is the amount of energy required to remove an electron from an atom. So hopefully that animation kind of helps you. Okay. So there's a periodic trend for ionization energy, just like there was for electronegativity and atomic radii. And for ionization energy, it's really similar to electronegativity in the fact that it increases going from left to right on the periodic table. This time it also includes the noble gases. Okay, now why does it increase going from left to right? With more protons, there's more positive charge attracting the electrons. So that means that there's more attraction. The atom is holding onto its electrons a lot as there's more and more protons. So because of that, it takes even more and more energy for it to lose those electrons. So as you go from left to right, protons increases, holds those electrons down. You have to add more energy to get those electrons out. So that's going from left to right. Going from down to up, it also increases. Now why is this? Electrons in the closer shells experience greater forces of electrostatic attraction. It's closer to that nucleus, so it's a stronger attraction. It's kind of like a magnet, like we talked about in the last video. If you put two magnets close together, you feel the attraction more than if they're really far apart. It's the same thing with protons and electrons. So as the electrons get closer and closer to the nucleus, it takes a lot of energy to get those to be removed. Okay, so the removal requires increasingly more energy. Okay, so I have a periodic table here, and this time I replaced the atomic mass with ionization energy. And as you can see, the ionization energy at the bottom decreases as we go down. So it starts at like 1300, now 520, 495, 418, 403, 373, 392. So for the most part, it decreases going down. Now so that means going up, it increases. And then going from left to right, you can see it kind of increases. 520, 899, 800, so it lowers a little bit, but then it just jumps right back up. 1086, 1400, all the way up to 2000. The most electronegative atom is helium. Okay, it's really holding onto its electrons. It really takes a lot of energy to ionize helium, to get those electrons to leave helium. Okay, so hopefully this periodic table and that video help you understand what ionization energy is. If you have any questions, let me know.